Today we are covering section 3.1, lines and angles. Okay. All right, write true or false for each one. This is our review here. And you can name a plane by capital letters such as A. This is true. Remember when we first started studying planes, we said that. We put a little A in the corner, capital letter. Okay, notice there's no dot by that A because it stands for the whole thing. We also put it off on the side of it before. Okay, so either place is fine with me. All right, number two, a plane contains a finite number of lines. So that means something that's less than infinite. So maybe 12 or 2,000 or 2 million, but not an infinite number. And this is false because every plane contains an infinite number of lines. Okay. All right, 2 points lying on the same plane are coplanar. This is true. That's the definition of coplanar, things that lie on the same plane. And if two distinct planes intersect, then they intersect to form exactly one line. And let's draw a picture of that one again. So there's one plane, and here's another one. Okay, and they're going to intersect at this line right here. Okay, and of course the planes go on forever, but that line also goes on forever. So this is true again. All right, vocabulary builder, we have parallel. And you learned about parallel in Math 8 and in Algebra 1. And the easy thing to remember about parallel is the lines never intersect. So there are two lines that never intersect. The harder thing to remember in Algebra 1 and Math 8 was that they have to lie in the same plane. But now that we know a little bit more about planes, we realize that this has to be true. So parallel lines go on forever and lie in the same plane. So I'm drawing them on this flat piece of paper. So they go on forever on my plane, which is the piece of paper. Okay. All right, circle the segments that are parallel to the x-axis. Let's see. So the x-axis is the sideways one. And the segments that are going to be parallel to it are going to be AB and CD. So we would circle AB and CD. Circle the segments that are parallel to the y-axis. So the y-axis is the vertical axis. And the segments that are parallel to that one are going to be AD and BC. So we'd circle AD and BC. All right, circle the polygon that has two pairs of parallel sides. So what are all the polygons here that have two pairs of parallel sides? Well, a rectangle has two pairs of parallel sides, including right angles. So this one's parallel here, and these two are parallel. A parallelogram also does. That's just a rectangle that's been knocked over. So there's our parallelogram. A square does. It's just a special rectangle with all the sides are the same. But a trapezoid does not. A trapezoid has only one pair of parallel sides. And the definition is written to say exactly one pair. Okay? So a trapezoid does not get circled. Complete each statement below with line or segment. A blank consists of two endpoints and all of the points in between. Okay, so that's going to be a segment. The segment has endpoints, lines do not. So this is a segment. It has our two endpoints and all of the points in between. By the way, there's an infinite number in between. Okay, and a blank is made up of an infinite number of points. Okay, so this one's going to be a line. Both of them have infinite number of points, but the line doesn't have anything in it about endpoints, two endpoints. Key concept, parallel and skew. All right. Parallel lines are coplanar lines that do not intersect. So they do not intersect. And skew lines are non-coplanar, but they are not parallel, but they still do not intersect. So in both cases, the do not intersect is there. The difference is coplanar versus non-coplanar. So parallel lines are on the same plane and don't intersect, and skew lines are not on the same plane and they still do not intersect. Okay. Parallel planes also do not intersect. If we look at this picture, which is meant to be like a box, the top of the box, a yellow plane, and the bottom of the box are parallel to each other. Okay. All right. So write each word, phrase, or symbol in the correct oval that would go with. So non-coplanar. Non-coplanar, that's definition of skew lines. So that's going to go over here. And then we have coplanar. That's in the definition of parallel lines. So these are lines that are on the same plane. So that's going to go over here. Okay, that's the difference in the two definitions. Parallel gets coplanar because the lines are on the same plane. Skew gets non-coplanar because the lines are not on the same plane. Do not intersect. This is going to go on both. Okay, because that's in both definitions. They never intersect. Intersect's going to go on neither one. The whole point of parallel and skew lines is that they do not intersect, not intersect. And then the next one, I think it's a little bit tricky. AE and CG, they're not marked parallel in here. It doesn't tell us in any of these things that they're parallel. It doesn't have the arrows, which you can show parallel with on here. But I know that AE and CG are meant to be drawn parallel in the eyes of the creator here because they're supposed to be part of our box. So they're going to put it in parallel. Okay. Now, technically there should be some marks to show that. All right, and then our last one, CB and AE, let's draw those in a different color. CB is the top right side of the box, and AE is the left front side of the box. These are never going to intersect, but they're also not on the same plane. So this guy is going to be skew. Okay. All right, so AE and CB, these two. Never cross, but they're not on the same plane. All right, so down below we have two problems here. Problem number one, identify the non-intersecting lines and planes. So use the figure at the right. Which segments are parallel to AD? This is what we're trying to figure out. Okay, so we want to answer these three questions. All right, to help us. So in plane ADHE, that's the front of the box. Okay, so this is once again considered to be a rectangular prism. So there's going to be parallel and skew lines in it. All right, even though they didn't mark them that way. So plane ADHE is parallel. So some segment is parallel to AD. So here's AD. And the segment that's going to be parallel isn't going to be AE or DH. It's got to be in the same plane though. So EH is going to be parallel. Okay. And then in the plane ADBC. So ADBC should really have been written ADCB because you're supposed to go around the polygon when you name it. And we want to know, that's the top of our box, who's parallel to AD here. So once again, AD is this one in green, and he's going to be parallel on our blue plane to the back part, which is BC. Okay. And then in the plane ADGF, this is the hardest one to see. So let me erase. Okay, so in the plane ADGF, so ADGF, that's a diagonal that cuts through the box. So who is parallel to AD in this one? Well, AD is going to be parallel to FG down here. So our big question was, which segments are parallel to AD? So there were three of them. Okay, there was EH, there was BC, and FG. So all the parallel segments here are marked in green. So in our second question here, we want to explain why FE and CD are not skew. So we have a couple questions to help us walk us through this. Okay. All right. So let's erase the diagram up here and then take a look at it again with new eyes. So cross out the words or phrases below that do not describe skew lines. Okay. So remember, skew lines are not coplanar, so we want to get rid of that one. They are definitely not parallel, so we want to get rid of that one. And they definitely do not intersect, so we want to get rid of that one. So the definition of skew lines are two lines that do not intersect, are not coplanar, and are not parallel. Okay. All right, so these two are kind of redundant because they can't be parallel if they're not coplanar. So really, we don't need the not parallel part. All right, number 15, circle the correct statement below. Segments and rays are never skew. Well, that's not true, because segments and rays are just part of lines, and lines can be skew, so segments and rays can be skew too. Okay, so segments and rays can be skew if they lie in the same, if they lie on skew lines or they're parts of skew lines. Okay, number 16, underline the correct words to complete the sentence. So FE and CD. So line segments FE and CD, okay, are in the plane that slopes from the bottom, let's see, left edge to the top right edge. So it's going to go from the bottom left edge, that's this guy, to the top right edge, that's CD, that's that one, okay? All right, why are FE and CD not skew? Okay, well, they're not skew because they are parallel. Okay, they lie in the plane, let's see, EFCD. So they're coplanar and they're parallel, which means that they're not skew. Okay, so to be skew, the lines that are skewed to EF, let's try that, would be not in plane AB, FE. They wouldn't be in plane FG, HE, the bottom, or on the top. They'd have to be over here on the side plane, and they could only be the ones that are going vertical. So DH and CG would be skew to FE. All right. So explain why FE and CD are not skew. They're in the same plane, and they are parallel. All right, let's flip it over and take a look at page 3. Key concept here. So angle pairs formed by transversals. So we're kind of switching it up a bit. All right, so alternate interior angles are non-adjacent interior angles that lie on opposite sides of a transversal. So this is important. Here are two lines. This is line L and M. Line L and M are cut by line T. So if one line crosses two other lines, then that line that crossed it is called the transversal. Okay? All right, so transversal is line T in this case because line T cuts across lines L and M. All right, so alternate interior angles are non-adjacent interior angles that lie on opposite sides of the transversal. Okay, so our alternate interior angles are going to be inside, so the interior is in yellow here, and they're on alternate sides of the transversal and opposite sides. So kind of think of it like this: 4 and 6 are alternate interior angles. Okay. Same side interior angles are interior angles that lie on the same side of the transversal. So in this case, 3 and 6 would be one set of same side interior. They're inside, but they're on the same side of the transversal, unlike 4 and 6. Corresponding angles lie on the same side of the transversal T and in corresponding positions. Okay, so corresponding angles are going to be something like 1 and 5. They're on the same side and they're in the same position. They're on the top left. Okay, 2 and 6 would also be corresponding angles because they're both on the top right. Okay. Alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. So just like our alternate interior, they have to be on one side of T, so the right side or the left side. So in this case, 2 and 8 would be alternate exterior. So the exterior is the blue part outside of the yellow. Okay. So use the diagram above and draw a line from each angle pair in column A to column B. So let's erase again so we can see what's going on. Make it a little easier. So once again, here are our two lines. They're being cut by this transversal to form 8 different angles. And first one we want to look at is angle 4 and angle 6. So angle 4 and 6 are in the interior, okay? And they're on alternate sides of T. So these guys are alternate interior angles, okay? 3 and 6. 3 and 6 are also in the interior, but they're on the same side as T, same side of T. So these are same side interior. And then we want to look at 2 and 6. 2 and 6 is one exterior and one interior. So it can't be same side interior or alternate exterior or alternate interior because there's one inside and one outside. So that means I think of something else. And in this case, these are corresponding. They're both in the top right. Okay. And then we have 2 and 8. 2 and 8 are both in the exterior and they're on alternate sides. So they are alternate exterior. Okay. They also have to be on different exteriors, so they're in the alternate exterior parts too. Okay. All right, problem number 2, identify the angle pairs. What are 3 pairs of corresponding angles in the diagram? Underline the correct word or letters to complete each sentence to help us figure this out. All right, so the transversal is which line? Let's see, well, we have 2 lines that are crossed by another one. So these are the 2 lines, and they're being crossed by this line. So this time the transversal is line R. R goes across M and N. Okay, so corresponding angles are on the, let's see, corresponding, they're on the same side. Okay. All right, then we want the transversal. Okay, so 4 and 2 would be in this. So like, remember corresponding is like top right, top left, bottom right, bottom left. So let's name the 3 pairs of corresponding angles. There's actually 4 pairs here. All right, so our first one would be the top left one with this top left one. So angle 1 and angle 3. Okay, and then our second pair would be top right with this top right. So 2 and 4. Okay, and then our third set would be bottom left with bottom left. So 8 and 6. And then our fourth set, because there are always 4 sets of corresponding angles, are going to be 7 and 5. So it asks for 3, but then it gave you places to write all 4. So we'll do all 4. All right, classifying an angle pair. Are angles 1 and 3 alternate interior, same side interior, corresponding, or alternate exterior? Well, let's see. Angles 1 and 3. So here's our transversal. So we'll go ahead and mark him in to help us find it. Okay, so that means that in here, in the green, this is our interior and our exterior is outside of the green. Okay, so are they on the same side as the transversal? So 1 and 3. This is yes. So now we have a choice. We can do corresponding or same side interior. All right, so cross out all the angle types that do not describe 1 and 3. They are not alternate exterior. They're not both in the exterior. They are not alternate interior. They're not both in the interior. And they're all on the same side, so the alternate part messes up. Corresponding, this is good. And same side interior is bad. Same side interior is bad because they're not both in the interior. We're talking about angles 1 and angle 3, and one's outside and one's inside. So they're going to be corresponding. So angles 1 and 3 are both in the top left. So these are our corresponding angles. All right, let's flip it over and see what's on our last page. On the last page, we have 2 lesson checks. Do you know how and do you understand lesson check? As always, pause the video here, try these yourself, and then unpause it and come back and check your answers. Okay. Parallel segments. So we want to know who's parallel. So AB is parallel to, and we only have to name one pair here. So we could say EF. Okay, they're both on the back left side. We could also put HG or CD there. Those are all possible answers. Skew segments. HD. We want to know who is skew to HD. So skew, let's see, it's going to have to go the opposite direction. So can't be CG or FB or EI. They're all going straight vertical. So it's got to be horizontal ones. And the horizontal EH doesn't work. It's in the same plane. But FG would be okay, and so would BC. So I'm going to go with FG. Okay, but you could put BC there. And then our parallel planes. So who is parallel to ABCD? So ABCD is the bottom of our box. So the only thing parallel to that will be the top of our box, which would be EFGH. Okay. Number 31, name one pair for each angle. So alternate interior with angle 8. Okay, so inside is in here. So between these 2 green ones. So this is our interior. Exterior is out here. Okay, and that's because our transversal is this one. Okay, so we have 2 lines that are cut by that blue transversal. Okay, all right, so we want to know alternate interior with angle 8. Well, interior is in the green, and on the alternate side of 8 would be 6. So 8 and 6. same side interior with angle 8. So same side of the transversal is going to be 8 and 3. These two are going to match. Okay. Corresponding with angle 1. Angle 1 is our top middle here, I guess. Best way to describe it. So if we look on the other part where the other line crosses transversal, the top middle would be angle 3. Okay. And then alternate exterior with 7. So alternate exterior, well, 7's in the exterior, that's over here. And then on the alternate side, 5 is in the exterior. So 7 and 5. All right. Lesson check. Do you understand now? Carly and Juan examine the figure at the right, and Carly says that AB, that's this one, is parallel to HG. Okay. And Juan says AB and HG are skew. Okay. So the question here is who's correct? So really we want to know, clearly these aren't going to cross, so all we need to know are they in the same plane or are they not in the same plane? Okay, and that's what's important here. So parallel segments are coplanar. This is true. Okay, there are only 6 planes in this cube. This is false. Okay, there are the 6 sides of our cube. However, there are more planes. There are the diagonal ones. So in this case, there's the one that these two lie on. This plane right here. These 4 points connect to make a plane. There's also the CDFE one. And then there's the CBFG and the ADHE plane. Okay, so no plane contains AB and HG. This is false. Okay, it is contained in that plane, ABHG. So who is correct? Carly is correct. I'll spell this right here. Carly is correct because let's see, AB and HG do not intersect. Okay, that's the first part of parallel, and are coplanar. That's the second part of parallel. Okay, because they lie on the plane ABHG. All right, so by the end of this lesson, you should know quite a bit of vocabulary, but some important ones on here are definitely parallel, skew, and transversal. And then there's some angle pairs. How well do you know those angle pairs? If you are down here in the 0 to 4 range, go back and look at them again. You really want to be up here, okay? So those angle pairs were on the top of page 3. Make sure you go back and look those over, and we'll practice them with some note cards next time, some matching games. See you in class.